Now, when I said 8 bits, I said every number within the octet. So we have like 4 numbers. So each number can be represented with 8 bits. Let's just go back in time, and then let's just do something that we might have done in the past. There's this concept of indices that we used to do in the past. And I think some places we used to call it powers. And so we're just looking at just the base 2 numbers. So we say 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. If you look here, if I say 2 power 1, 2 power 2, it's just 1, 2, 3, 4, 5, 6, 7, 8. These are 8 different 2 powers. The first one, 2 power 0, is just 1. 2 power 2 is 2. 2 power 1 is 2. 2 power 2 is 2 times 2, which is 4. 2 power 3 is 2 times 2 times 2, which is 8. 2 power 4 is 2 times 2 times 2 times 2 times, times 2, sorry. That's 16. And then we have 2 power 2 2 times 2 times 2 times 2. That is 32. And we have 2 times 2 times 2 times 2 times 2. I know I'm getting boring, but I just want to paint a picture. And then this is 2 times 2 times 2 times 2, 5, 6, 7. That's 128. Now, in order for us to get any octet, so the 4 numbers 10.0.4.7 or any number, for each number, we can represent it with this block. So what do I mean? In numbers, we've seen 0 to 255. This type of numbering is called the decimal numbering. But in computers don't see decimal numbers. It only sees binary. And so only zeros and ones. And so for every number we have in this octets, it has to be converted to binary. And in order for us to convert it to binary, that idea that I just showed you, the 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7 are very important. So 2 power 1, like I said, 2 power 0 is 1, this is 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. Now, when I said each number can be represented with 8 bits, it means that if we convert any number to binary within an IPv4 space, that number would become 8 bits. So let's just have a look at this example. The highest number I said we have for IPv4 address range will be 0 to 255. So the highest is 255. So 255 in binary will be 11111111. This is 255 in binary. I just want to explain how this is done, and then we'll come back to this whole idea of 8 bits. So let's just have this assumption at the back of our mind. Assuming you want to find the binary for 255. Assuming you just want to find it. Let's say this is how much money you have. And let's say that, yes, we have only 255 pounds. But we also have various shops that we can buy stuff from. And these shops sell the same items, but at various prices. And the prices they sell them at will be, the biggest shop will sell it for 128 pounds. The second biggest will sell it 64 pounds in that order, 32, 16, 8, 4, 2, 1. That's the various shops. Now, in order for us to do the conversion, the first assumption you need to have is that, first of all, whatever we want to convert is the amount of money we have. So we want to convert 255. So that's the amount of money we have. Secondly, what we want to get is basically in binary, these are the shops that we have to go and buy these items from. The third assumption is that wherever we're going to buy, we can only buy one from that shop. And also, the last assumption is that we can only start from the biggest shop. So I have 255 and I want to buy something. So I could go to the first shop, the biggest shop, and I can spend 128. If I spend 128 out of my 255, I get 127 left. So I still have 127 pounds. Again, another assumption I didn't add is that you're supposed to spend all your money. And so 127, I can still go to the next shop and buy one because you can only buy one from one shop. So that's 64. And if I buy something for 164, I have 3 here and then I have 6 here. So I have only 63 left. And so 63, I can go to the next shop and buy one. When I buy it, I have 31 left. So 31, I can still go into the next shop and buy one because that they're selling it for 16. And when I buy that, I have 15 left. 15, I can go to the next shop and buy. And when I buy from the next shop, I have 7 left. 7, can go to this shop and buy one. And then I have 4, sorry, I buy one and I have 3 left. 3, I can go to this shop and buy one because they're selling for £2 and I'll be left with £1 and I buy one from here. So as I said, the highest number we can have for any IPv4 address is 255, and we can represent 255 in binary using 8 bits. A bit is just a 0 or a 1. So if I say 8 bits, I mean a combination of zeros and 1, but we have only 8 different variations of the zeros and 1s. So like this one we have here is only 8 numbers, 8 zeros or 1s. So 1, 2, 3, 4, 5, 6, 7, 8.